So what is that? The previous class we studied the law of mass actions. That is given by Goldberg and Wedge. So what they says that if suppose A gas and 2B gas is going to convert to 3D gas and 2F gas, then according to law of mass actions, Kc will be product concentration divided by reactant concentrations, and the coefficients will get the power. So what concentration of product, that is D power F2, and the reactant concentrations A and C. So this is the given by law of mass actions. So the questions related to law of mass actions, first is like P power, and we know that some expressions for Kp and Kc. For the expressions for Kp and Kc, we already discussed that concentrations of solid each taken unit or constant, that is one, and concentrations of liquid with gas is taken as unit, and concentrations of water in aqueous solutions is taken as unit. So these things we already discussed. So here, so from law of mass actions, if this is the reactions, then for this Kc will be what concentration of product divided by concentration of reactants. But the concentration of product here, that is solid. So solid concentrations with gas is taken as unit, so it will be take as 1. And here also in the reactant also concentrations of solid is given, and concentration of solid is taken as unit with respect to gas or liquid. So this is also unit 1. So only remain is O2. And concentration and coefficient is 5. So this. So option A is the correct answer. Next, for these reactions, what given? 3A gas plus B gas, that is given to C gas, and Kc is given as 9. So what must be the volume of the flask if the mixture of 2 moles of each A, B and C exist in equilibrium? So at equilibrium, they are saying at equilibrium moles given, that is this is 2, this is 2, this is 2. So at equilibrium each of ABC exists as 2 moles. So at equilibrium concentrations will, so we are taking concentration is moles for volume. Concentration you are taking generally molarity, that is moles per volume. So for concentration 2 divided by volume, 2 by volume, this is 2 by volume. So according to law of mass actions, Kc, that is equilibrium constant, equal to product concentration divided by reactant concentration. So product is here 2p, and since this is 2 coefficient is there, so this will be 2 by b into 2 by b. And for reactants, this is 2 by b, that is 3 times, because to the power 3 coefficients will get raised to power 3. So this is 2 by b into 2 by b to 2 by b, and b is 2 by b. So this cancelled. So remaining is, that is b by 2 into b by 2. And Kc is given what, 9. So what we will do? So 9 equal to b square by 2 square, that we can write this as 3 square, then b by 2 whole square, so squares cancel. So 3 equal to b by 2. So B equal to 6 liter. So option A is correct. Another questions regarding law of mass actions, that is N2O power gas is going to convert to NO to gas, and concentration of N2 and O4 at equilibrium are this and this respectively, the value of Kc. So Kc is equal to concentrations of product, that is NO2, and coefficient will get power, and reactant is N2O4. So NO2 how much given? The concentration of N2O4 is this, and concentration NO2 is this. So NO2 concentration is 1.2 into 10 raised to into 10 raised to minus 2. So 2 times, because this power. So 1.2 into 10 raised to minus 2. And N2O4 is only 1. So that is 4.8 into 10 raised to minus 2. So this cancel. And 12, 3 12, 4 ja 48, and 4 3 ja 12, that is 0.3. So 0.3 into 10 raised to minus 2. So this is 3 into 10 raised to minus 3. So this power, if you this 10, so this will become 10 raised to minus 1. So minus 2 minus 1 minus 3. So 3 into 10 raised to minus 3. So option A is correct. This much smaller. So next topic we have studied the relationship between, another good concept is the representations of Kc, and so we study the relationship between Kp and Kc. So that is Kp equal to Kc RT delta X delta Ng, where this Kp is at atm and Kc is generally represented in moles per liter, and R is gas constant, that is 0.082, that will be atm. So that this value should come atm. So atm liter mole inverse Kelvin inverse, and this is obviously Kelvin. So if you if you cut everything, then you should get atm. So moles, this moles, mole inverse cancel, this liter inverse liter cancel, this Kelvin cancel. So atm only left, and this is atm. So the gas constant, that unit is right. So you can check, because both Kp and Kp and this is atm, then this reactant side, this product side also should come atm. So this atm has to be same. So this is atm, means this whole product will also should come as atm. So in this way we can check the unit of any value. So if everything is cutting, this is atm, so this is also atm, then our assumption is correct. So this is the right. So we will solve using these relations. There are a lot of problems. So let's check some examples. So this is the questions, like N2 power gas is going to give 2NO2. So Kp is bound to be equal to Kc. This is attained when So we know the relationship, that is Kp equal to Kc RT delta Ng, where delta Ng is number of moles of delta Ng equal to number of moles of products minus number of moles of reactants. So here Kp equal to Kc RT delta Ng. So for these questions, the for product side is 2 and from reactant side is 1. So this is Ng. So delta Ng is equal to 1. So for this delta Ng is 1 and the Kc is R we know, that is 0 0.082 atm liter mole inverse Kelvin inverse, and temperature we have to found at which temperature this will be equal. So if we put we can put the Celsius, so if it is in Kelvin, so this if you convert, then this will be 273 Kelvin. So 0 degree equal to 273 Kelvin. So if we put this value 273 and if we multiply with this, then we can't get 1. If we get 1, then only Kc equal to Kp. So for this this will not good. This is not match because 0.082 into 273, that has to be get 1. So that Kp equal to Kc into 1. So that is Kp equal to Kc. So option A is wrong. So what we will next is if we put 273, so 0 degree centigrade into 273 Kelvin, this is same, so this is also wrong. And if we put 1 Kelvin, then also Kc into 0.082, so it is not getting 1, so you want this value as 1, so this also not match. Then if you put 12.19 into 0.082, then what is the value? So this is getting 0.99. So you can take as unit. So Kc into 1 is equal to Kp. So option D is correct. So another questions related to that relations between Kp and Kc. So you know Kp equal to Kc RT delta Ng. So for this delta Ng equal to 1, product is 1 and reactant is 1 plus half, that is 1. This is become 3 by 2, then this is become minus 1 by 2. So here Kp equal to Kc RT delta Ng is minus 1 by 2. So they ask what is the value of x. Oh, so this is the relations, and they say that Kp equal to Kc RT x. So if you compare this and this, then we see that delta Ng is equal to x. So x equal to delta Ng, that is equal to minus 1 by 2. So option B is correct. Again, the related to relations between Kp and Kc, this what says. So we know Kp equal to Kc RT delta Ng. So here Kp Kc delta Ng value is here 1 here. So delta Ng product side 1 and reactant side 1 plus 1 by 2, that is 1 minus 3 by 2, that is minus 1 by 2. So this is minus 1 by 2. So Kp by Kc. So Kp by Kc equal to RT minus 1 by 2. So which C is the correct options. So another terms we have discussed, that dependence of equilibrium constants. So it depends, but equilibrium constant depends, first is mode of representations. Mode of representations of the reactions, the equilibrium constant depends. How? First is, suppose this is A gas plus B gas going to give C gas plus D of gas. This is suppose K1. And if I multiply the factor n to the balanced chemical equations, that has to be balanced. So I am multiplying plus n then this K1 is getting what? This is if you multiply the balanced equation by factor n, that then the equilibrium constants get raised to the power of that factor, that is n. Example, if I say this is, let's give the examples. If 2a gas, sorry, A gas plus B gas is going to give C of gas plus D of gas. Suppose this equilibrium constant is K1, and suppose I am multiplying by factor 2 to this equilibrium, this balanced chemical reactions. I multiplied each by 2, then this K1 here get raised to the power of that which factor I multiplied. Suppose I multiply 2, so this will become 2. And similarly, if I divided by 2 by both, then it will also become the square root of that factor 1 by 2. So here actually basically what I am doing here, 1 by 2 is multiplied every side, so here also 1 by 2 get raised to power 1 by 2. So this is the one mode of representation. So this is how the change. If we multiplied the chemical equations by factors n, then the chemical equilibrium get raised to the factor of that factor which we multiplied. Then the next representations, this next mode of representation is, suppose A gas plus B gas, C gas plus D of gas. Suppose this is K. And another is, so if this gas, if I reverse that, C gas plus D of gas, F gas plus B of gas, if I reverse the chemical equations, then our equilibrium constant get inverted, that is 1 by K, that become reciprocal. Another mode of representation, suppose A gas plus B of gas, C of gas plus D of gas, this is K, and another is E of gas plus F of gas, G of gas plus H of gas, and this is K1. If I add these reactions, then A of gas plus B of gas plus E of gas plus F of gas, C of gas plus D of gas plus G of gas plus H of gas, then this equilibrium constants get multiplied. So if I add the two chemical equations, then the corresponding to that chemical equations will get multiplied. Similarly, if I subtract the two chemical equations, then the chemical equilibrium constants of that chemical equations get divided. So if I subtract, then that will get divided. And okay, so let's solve some problems. So this is the example. So this is N2 gas plus O2 gas going to give 2NO gas, and at temperature T is this. So the equilibrium constant for this is given 4 into 10 raised to minus 4. The value of Kc for the reaction. So that they given NO gas half N2 gas plus half O2 gas. So for this equilibrium constant is this, and they ask the what is the equilibrium constant for this. What is the equilibrium constant for this reaction? So what they did, just reverse this. So if they reverse it, then what that will get inverted. So if the chemical equations is reverse, then the equilibrium constant get inverted. So this will become 1 by 4 into 10 raised to minus 4. And what they did here 2, so they div just divided by 1 by 2 to each of the molecules. So what you will do, you will raise to the power 1 by 2. So they basically what they did, they reverse it and they multiplied by 1 by 2. So chemical equilibrium constant that will be get 1 by 2, and since they reverse, then it will get inverted. So this is the K. So if you solve it, then what will the answer? Root 1 okay, so 1 4 into 10 raised to minus 4, that is 1 by 2, also 1 by 2. So that is root 1 is 1. So this is 2 into 10 raised to minus 2, because this is 2. So 4 2s are 2 4s are 2. So 2, and this is 2 square. So 2 2 cancels, so 2. So this is Kc, and this is the K. If I take to the power, if I take to denominator, then numerator, then this will become 10 to the power 2, then 2. This is 100 divided by 2, that is equal to 50. So B is the correct options. Another question is related to that. So what this is, SO2 gas plus half O2 gas, that's going to give SO3 gas, and this equilibrium constant they given 4 into 10 raised to minus 3, and they ask SO3 Yes, this. So for this, what? So they ask. So what they did? They basically just reverse it. This one, they just reverse it. So if chemical equilibrium is reversed, then this get inverted. So this is first do invert 1 by 4 into 10 raised to minus 3, and they multiplied by 2 to each factor, so it will get power by 2. So k equal to 1. This is 4 persistence. This is 10 raised to minus 6. So if you do this, then this is 10 to the power 6 persistence, and this is, if you solve it, how much? This is distance. So suppose 100 divided by distance, then what? So this will come 6.2. So yes, so option D is correct. So solve it, it will get D. Next questions. So what they give, that Ag plus NH3, that is going to give Ag NH3 plus, and this value they given, that is 1.6 into 10 to the power 3, and Ag NH3 plus NH3, that is going to give Ag NH3 2 plus, and this K2 is given as 6.8 into 10 raised to 3. So they ask the formation constant for AgNH3. So what is the formation constant for this? So what you will do basically, so let's, they ask that AgNH3 2 plus. So what is the formation constant for this? So basically what you will do, just add it. If you add this gets subtract, then Ag plus NH3, that is going to give this value. So this is equal to what? So if you are actually basically adding these two values, after that you are getting this one. So if we add the chemical reactions, then this will get multiplied. So K1 into K2 is the value of this. So what? So K1 is 1.6 into 10 raised to 3, and K2 is 6.8 into 10 raised to 3. So just multiply it. This will become 1.6 and 6.8, that is 10 raised to power. So this is basically comes, that is 1.0. So this option D will come. So just solve it, you will get D. So these types, like mode of representations, they will ask questions by giving the